Welcome back to vectors in two dimensions. Let's look at difference of vectors. The difference of two vectors, u and v, is defined by the vector u minus the vector v equals the vector u plus the negative of vector v, where negative vector v is equal to -1 times vector v, and is the vector that has the same length as v but opposite direction. And you saw this in the previous video where you had a -2 times a vector. To find the difference geometrically, use the parallelogram. If you take this picture here and you look at u and v, and you recognize that v goes to the top right direction, negative v will go to the bottom left direction. You, of course, could also sketch this using the terminal point of the first vector connected to the initial point of the second vector, and then you could combine them. So either way, it works. Let's sketch 2u, vector u, 2 times the vector u, minus the vector v. Now I know that the vector u is this vector here, this little vector. So I'm going to sketch an equivalent vector here. And I know I'm subtracting v, which means I'm going in the opposite direction. Which means this vector I just sketched is going to the bottom right. Its displacement is toward the bottom right. And the original vector v was displacing to the top left. So now if I want 2 times the vector u minus the vector v, we'll just take the u vector, and here's my second u vector. Now I have 2u, and now I want to add a negative v. So I'm going to take this vector here, the negative v, and I'm going to add it, but I know it's negative. Now, keep in mind that this vector that I doubled is equivalent to just 1 2 vector times u, and then I'm connecting the negative v vector, and then if I connect the initial point I started at with the final displacement location over here on my negative vector v, I will have my new displacement vector given here. So this is the vector 2 times the u vector minus the v vector. Now let's look at vectors in the coordinate plane. To go from the initial point of the vector v, as shown, to the end point, we move a units to the right and b units up. So we can write the vector v as equal to open pointy bracket a comma b close pointy bracket. It's kind of like coordinate points, but not quite. We note that a is the horizontal component and b is the vertical component of the vector v. We also need to note that the vector v has many different representations in the plane depending on its initial point. So two vectors are equal or the same if and only if their corresponding components are equal. So if we look at the vector starting at -3, +4, and then terminating at 1, 2, we can see that that's equivalent as a vector to starting at the coordinate point 0, 0 and ending at the point 4, negative 2. Their displacement are the same.